Unlike in geometry, it is entirely possible to have negative area in calculus. Basically, it's like this. Say we have some function going like that. Any area above the x-axis is positive. Any area below the x-axis is negative. It does not matter which side of the y-axis the area is on, only which side of the x-axis. Let's write that. Area above the x-axis has a positive signed area. Area below the x-axis has a negative signed area. Which side of the y-axis the area is on doesn't matter. Let's look at an example. Approximate the integral from -4 to 4 of x with respect to x using left Riemann sums with width 2. So the first thing is to realize that the equation y equals x is just a straight line like that. 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, and so on. 1, 2, 3, 4, 5, 2, 3, 4, 5. So we're going from -4 to 4 with 2. And we're using left Riemann sums, so that means that we're going to take the left side, go and touch the line, then draw over until we come to our next one. Notice if we're going down to touch the line, that's the same thing. We're still touching that left corner for the left Riemann sum, even if we had to go down to do it. So for our next, we're going to take the left side, touch the line, and then draw across. Here we're going to take the left side. Notice that the left side is actually on the 0 mark. So y equals 0. Touching it right now, I don't have to go anywhere. I'm still going to draw my rectangle over. My rectangle has 0 width, but that's okay. Then here, this is more normal. We're on the left side of this interval. We go up, we touch, and we draw over to the right side. Now we want to find the height for each of these. It's just y equals x. So whatever the x coordinate is, that's the y coordinate here. So this is -4. This right here, -2 high. This right here is 0 high. This right here is 2 high. So the integral from -4 to 4 x dx approximately equals, this width right here is 2, this height is -4, and here it's the same thing, it's just height times width times height, I should say, and if the height happens to be negative, height's negative, so what? This also has a width of 2 and a height of -2. This little flat one right here, it also has a width of 2, it has a height of 0, that's okay. This one has a height of 2, width of +2. So we just add this up, -8, -4, 0, 4. The area is approximately -8. So, check for understanding. Estimate the integral from -2 to 3 of -x squared dx using trapezoidal Riemann sums with intervals of width 1. Okay, try that on your own and restart the video when you're ready. Pause the video now. Okay, here's what I got. So I sketched my curve. I said we're going from -2 to 3 with intervals of width 1. So since I'm using a trapezoidal sum, I drew each line down, in this case, to the curve, since these are going by 1. And then I connected those to make that little trapezoid. And then I used this formula to find the height of each of the lines that I drew. So -2 squared times a negative is -4, and so on. And then for the trapezoidal sum, we have to find the average height for each trapezoid. So right here, I took this height plus this height, divided them by 2, and then multiplied times 1, which is the width. So I got this -5/2. I did the same thing for each of the other 4 trapezoids. Then when I added up that height, I got -25/2, or -12.5.